Hello, hello, hello. Advent of Code Day 2 in less than a minute. Looking forward to it. Day 1, pretty good. It had math in it, of course, so I had to fight the math, but aside from that, relatively good. Pretty happy with how it came out. Excited for Day 2 and the rest of them. Also, did figure out my twist this year. I'm just going to go through the 12 again on days 13 to 24. So, I got screencast mode on. Let me turn Quokka on. Get that loop nice and fast. Get my command. Well, I just killed my terminal. That's okay. I will get the input myself. Let's do this. Lots of words. It's a date, kind of UUID-ish. Maybe it's a date. Who knows? We'll have to read it. Get out of there. Okay, that's a thing. We have lots of things. Adding up the invalid IDs. Gotcha. Okay. So I have to parse out invalid IDs. Give me my input. There we go. Truncate the extra bits there. So I have to go through all of these and get out the valid IDs. Why are there two lines? In your input, they appear on a single line. Ooh, okay. That's a good gotcha. Would have really got me. Okay, so let's do the first thing. Const IDs equals data. Trim the string, split it by what appears to be a comma, and boom, we have raw IDs. What are we supposed to do with these again? I didn't read. Okay. So things are separated by hyphens, invalid IDs in the given range. Why? What the heck are these? Ranges. Oh, these are ranges. First and last ID. Okay. So ranges. For range of ranges. I know how to spell ranges. We first, first, last equals range split on the hyphen. Are these always numbers? They always appear to be numbers. Shall I treat them as numbers? I shall. Map you to the little number constructor. First and last. Great. Now, why invalid? Who said invalid? What are rules for invalid? Any IDs made only of the sum sequence of digits repeated twice. Basically, if they have any duplicate characters. No, wait. 1, 2, 3, 1, 2, 3. Why don't you count that as duplicate for 1 and 1? Why do you say that is um as an invalid ID? Ooh, the range of numbers. Okay, so that's gonna be optimization that I'm not gonna get out of the gate. It's two invalid IDs. So I loop through it and I just detect if character ever appears twice. Contains no invalid IDs. Adding up all the invalid IDs in this example, so 11, so adding up all these highlights gives me that. Okay, I did just make an assumption there, so let me do some quick math here. So you're saying all that gives me that. And then deep strict equal, let me get all the apparently invalid IDs, so 1185 222 446 446, and I am not typing that thing out. So it's saying if you add all these up together, you get the invalid one. So assert that this equals the big ol' invalid one, which is right here. That's the claim, right? Probably should move this one up so it can actually run. Okay, that's the claim. Assumption validated. Gotcha. So, okay, I can just do this and detect if anything ever repeats twice. I'm not understanding this pattern. None of the numbers have leading zeros. Some sequences of digits repeated twice. Oh, okay, so it needs to be the same sequence repeated twice. So it needs to be an even lengthed number. That's easy filtering. And then slice half, slice second half. Okay, there's probably a mathematical way of figuring that out. I can't think of it though. Okay, I think that's enough. Let is valid equals true for I equal first, I less than or equal to last, I plus plus. Go through all of them, and then dots. We'll already have I constant string length. Basically, if it's even, then you could be a bad one. So cost front end equals string dots. Well, it's not that. It's slice from 0 to length divided by 2 probably, and then I really kind of, this is all mucked up, but that's okay. We'll figure it out. And then the other one is string slice. Yeah, very inefficient, I'm aware. String length divide 2. Okay, did I write any of this correct? Front end, I kind of need to know what string is, though. Okay, 11, 12, 18, 1, 8. Okay, columns are all messed up. That seems good. Okay, basically now we can check if they're the same, then not valid. Equal end is valid, equals false. Let's make this a little more readable, so that way I could do a break early. Also, in this one, if not is valid. So while this is true and stuff's valid, can exit early. I have to add up all of the invalids that I find, though, which means I can't actually break early. They're all only finding one, so that might work, but I'm not going to risk it. I don't think the performance is too terrible here. So, invalids is actually an array. That's all the ones I'm finding. And I won't exit this early, so... went a little bit in a circle, but it's okay. Valid to push the current one, I, right? And then I'll just add up all the invalid IDs. Total equals 0. I could have done this differently, but it's okay. Plus equal invalids. Reduce A, B, A plus B. It could be empty though, so start off at 0, and then I return the total. Not the title, the total. Total. There we go. Math has math, and it ran very fast. I'm very scared of the part 2 optimization that will destroy this algorithm. Boom! Okay. Destroy my algorithm. If it's made only of some of the sequences... God, the sentence just hates I hate reading the sentence for some reason. 1, 2, 3, 1, 2, 3, 1, 2, 3, 3 times. Oh, at least twice. Okay. An ID at least twice. So same rules, but it also counts multiple. Twenty-one, 21, 2. Okay, I'm somewhat understanding it. Processing delays here. Ah. Okay, so how am I human? How do I figure this out? Still has the one invalid ID. Yeah, that one didn't change. Okay, where's the new one? Now has 2, 99, and 111. So when it's odd, it's somewhat sliding window. Now it's 2 invalids, that or that. Wait, so am I just looking for 3? Oh, this one has it 7 times. You also could have figured that out. Okay, so I'm doing it up to the half length of it and repeating that, seeing if it equals the chunk. Okay, I somewhat understand it. I did not explain it well, but you have to roll with it. Thankfully, most of it is the same. I need the exact same sample. That makes things nice. And the output, of course, not the same. I could have closed that bar this entire time. Real estate. This number goes here. I am typing into insert mode. Cool, that's not the home key. Come on, there we go. So what I need to do is not do this whole thing bob here. I need to made a sliding window basically just grow and be like, hey, I'm gonna check the 4. Do you have 15 fours? Nope. Do you have 7 44s? Do you have 3 4 4 6s? All the way up to the middle, and then check if that's the thing. So that'll be the chunk size will go from 0 to strength 1. So let CS equals 0. Well, CS can't be 0. CS is 1. CS less than or equal to string dot length by 2. This is going to wreak havoc with the odd ones, but that's okay. So I'll do that. Extra computation never hurt no one. It ran pretty fast. So const big equals string slice from 0 to CS. Repeat. Okay, I'm going to do the bad thing here. 100 slice 0 to string length. Why do math when you just make CPU do extra work? And now if big equals string, we found an invalid. So grab, paste there. Big equals str. Good, goodbye. Didn't work. I'm off by a couple 100K. Well, thankfully my example actually tells me what's going on. So, hey, who are you? So which ones am I supposed to find? 11 and 22. Okay, yeah, this isn't obviously working. Greater than or equal to. There we go. We weren't going through enough of them. Wait, am I literally... Oh, I can't read this actually, but it's not working. So let's see what we got here. We have 11, 22, 99, 111, 999, 10, 10. We have 108. We have the 2s. We have the 2s. We have the 2s. Oh my gosh, we have the 2s coming in like 17 times. Okay, once you find your invalid, you can go home. It's running fast, or whenever Quokka slows up like that, it means you're running a lot of loops. Dang it. Well, we have our first failure. That wasn't it. Maybe I should read, see if they got any gotchas. An ID is invalid if it is repeated at least twice. So this, okay, so I'm doing a bad trick where I'm like, hey, 100, we'll never go 100 long. Okay, first kill that. That's the same bad assumption I made about the other stuff. Yeah, these are big numbers. Let's go. Eat all my memory. Now I kind of need signs of life here. Is that number the same as the other number? About to find out. Dang it. Okay. So, this isn't the trick here, unfortunately, which means I am not seeing the problem. An ID is invalid. Okay, so 2 invalid IDs. Oh, wait a minute. If only some... Okay, the whole... I guess there's no such thing as an invalid range. An ID is invalid if it is made up of the sum sequence of digits repeated at least twice. Am I doing a once invalid here? Basic check for equal 1, continue, get out of my life. Have I done something bad there? I really need a sign of life down here. Okay, same thing. Okay. What am I missing? What do you get up if you add up all the invalid IDs using the new rules? Okay. Make sure this number hasn't changed. Nope. Paranoia is getting to me. Nope. Okay. So I'm doing what I believe to be logically correct. It must be an assumption in the data. Trying to wrap on, see if I can pattern recognize my way out of this. Ooh, my assumption is that these are ordered from smallest to largest. I'm also including the last one. If greater than last. Okay, that assumption is valid. They're in the correct order. We have some big numbers here. Are we dealing with like weird big int stuff? I'm not seeing numbers larger than 2 billion though. Pretty hefty ranges. Hilariously enough, the range concept didn't really do anything. I'm not seeing it. Am I counting them duplicate? Ooh, maybe I don't count an ID twice. Ranges can be overlaps. That's a theory. Invalids, congratulations. You're now a set. You've been upgraded. Valids, add I. There you go. Get rid of that. I've also pluralized you. Yay. You need to be back to an array, so I will spread you. Drop that. You're a set of numbers. Be chill. Be cool, TypeScript. We're friends. Did I not save you? Great, this is a number. Is it the same number as that number? It is. Dang it. Okay, my second theory has failed. We're not seeing the duplicates. I am breaking here. What happens if I just don't? Do more math. Also, this might be a problem. Let me check. Oh, that's not where you put that. Give it, give. Okay, fine. It's gone. Okay. What's the most janky part of this code? This thing right here, right? The length thing might not be going far enough. So let's go all the way to string length. Boom. Not worry about math there. Ooh, Lord. Oh yeah, that would never. Or that would. Yeah, that's illogical. Can't go there. The repeat. This is also the jankiest part of it. I need to repeat the number of times that. Yes, I need to do the math, right? So let's return 5 and let's look at some stuff because I don't know what else to look at. So we have thing and then we have a string. So I just need to get the length of it versus the length of that and see how many I need to multiply thing length to get to string length. Times equals length divided by thing length. Might have done that the wrong way. 2. Okay, and then big will now be all of that repeated times, and it shouldn't need any slicing. Well, those odd shaped things are gonna bite me. But let's just see if we can get through that. Yeah, we know 5's not the right number. Oh, number changed. Number changed. Hey, okay. I don't know what I did wrong, but identifying the jankiest piece of the code and replacing it with what it should have been, the proper calculation, did the trick. I'm starting to notice a theme of these this year. Just do it simpler. Don't get fancy. Solution works. Okay. Well, with that, well, we're going to commit, obviously. Now, get rid of date now. It's not useful. There's that. I'll leave that there for history. I'll get rid of that. And it's saving time. Get add 5. Boom. I think I figured out my messages. Not Lagoo. There we go. Add TypeScript solution. for day 2. There we go. So before we clean this entire mess up, let's dive straight into what the heck they wanted us to do. So, I'll probably read this too now. Okay, so what they've done is they've given us a bunch of ranges of IDs. I don't know why they gave us ranges of IDs. The whole range aspect ended up not at all being useful. There's potential that the ranges could have overlapped, but I didn't see that. So the ranges is kind of just a obstacle or a thing for the reader to do. But these are ranges or IDs where you have a numeric ID hyphen another numeric ID. They are always in the order of smallest to largest. And then these ranges are separated by commas. In the input, it looks like you get multiple lines. They clarify in parentheses, and in the real input, you don't. So it's one giant line. Oh, and it actually does say in the thing, you do get first and last. And within these ranges, you are supposed to go through them, go through from 11 to 22, for example, and add up the invalid IDs and just sum all the invalid IDs found and return that sum. But what's an invalid ID? Well, that is an ID that its entire value is a sequence repeated twice, which means it gives good examples here. So by the rules of its logic for part 1, it has to be even. You can't have an odd thing made up of the same thing twice. But it means that the first half must equal the second half, and that is considered invalid. They'll also never give us a leading 0, which is nice of them. Then we add them all up. I'm not sure. Honestly, from the problem itself, there's much more explanation for the particular ask. I mean, these are... can do a little bit more on them, but... you can see that 1, 2, 3 is 1, 2, 3 duplicated. And that's the same for all of them, and it's not possible for the other ones because, well, even this way, right? Like, there's no way to duplicate the same sequence and result in a odd lengthed number, or rather a number with an odd amount of digits. Yeah, so explaining how we figure that out, we start off by getting all of our ranges. Let me turn off the big runner here so we don't destroy our console. We turn these off too so we actually get fast outputs. So we start by generating our ranges. And the way we do that is we take our data string, which looks like this, just big old string. And first we trim it, because it's Windows, and there can be new line characters, and character turns, and all kinds of scary stuff. And then we split it by a comma, resulting in an array of individual ranges. Exactly how they said it. Then make this total variable to keep track of our total. And we'll go through each of the ranges. And the reminder will look like that. Then we parse out the first and last values. Okay, wow, you're not going to help me there. Oh, I know how to do this. Don't find first. What are you doing? Oh my gosh, okay. I am trying to be really fancy. Okay, finally get that to work. So yeah, we have range, which is the raw string, and we split that string by the hyphen, which gives us an array of 2 numbers. Those numbers, though, aren't numbers yet. They're strings. So we need to convert them to numbers. I use the old trick that map technically takes any function and pass it the constructor of the capital N number. I also could have said number string. These are functionally equivalent, though not technically because I'm using an arrow function here. Also could have used parse int or unary plus operator here. All leads us to the same place. I like this. It reads beautifully. And that gives us an array with 2 values in it. And of course, since I know there's always going to be 2, pull out some destructuring into beautiful variables. Now, here I keep track of all the invalid numbers. This is going to get refactored very soon. And I start iterating through them. First easy iteration here, or improvement. I'll rename this symbol current. Please rename. There we go. So we're going from the first number up to and including the last one. We don't want to leave the last one out. That actually makes it fail. So less than or equal to. Then I get lazy. And I'm like, I'm going to go back to manipulating strings instead of doing some fancy mathematical digits with the number 10. And I just turn back into a string. Ta-da! Now, based on the rules of part 1, where it needs to be made of the same sequence repeated exactly twice to be a invalid ID, I only look at things that are divisible by 2, which means are of even length. You can tell that. I don't know if we'll actually be able to see an example here because we have so much noise. I will find as an example. So I'll just console log it. So full diff. No, just don't do that. Eventually, we'll see a 3-digit character come around these parts. There it is. We didn't have to scroll far. You see 100. We don't even need to look at this. It's 100. It cannot be made up of 10 twice, or it can't be made of 1 twice. It can't be made up of anything twice. It's odd length. So we don't want to look at it. So we use that if it's divisible by 2, or if we divide it by 2 and its remainder is 0, to only look at things that are of even length. So we skip all those hundreds, we go straight to the 4 digits, and everything else is of even length. Divide all that. And then I do a little tomfoolery here. What we want to do is we want to get each part of that string cut in half. Now, my approach changed in part 2. I don't know which I'll end up on, but it takes the string and we just cut it in half. Since we know it's even, we don't need to worry about that middle character. So we slice it starting at the first character, ending before the last one, and then that gets us the first half of this. For the second half, we start at the ending character, and if we don't provide a value, it will go all the way to the end of the string. This gives us the front half and the ending half of the string. You know, let's actually bring the entire family together. There we go. Oh my gosh, please come back semicolon. Yeah, so 11 turns into, let's look at a more interesting one. There we go. Well, these ones are fun. Yeah. We can actually see with our eyes that the entire thing is this. The front half is 11,885. Back half, 11,880. And then eventually, we can just use our eyes and see they end up matching. Now, the way I did this, the slicing part I already explained. For code golf / typey reasons, this is where my fingers end up. I did put them into an array for the sole purposes of destructuring them out of the array into variables. Just the way it ended up feels nicest to my eyes. Once I had these out, I checked if the front half was the same as the back half, and if so, I threw it into my list of invalids, which I ended up just adding up at the end. I believe there was some extra logic around a range being invalid and us stopping the range early or doing other stuff. But in hindsight, I didn't need to do that. So I could have straight up added this to total, which is one little refactor we'll make right now. After I explain this last bit, where we go through all the invalid numbers. Here we go. And then we use the classic reduce loop, or it's not a loop, it is a loop, but the reduce method on the array to take all the values in the array and sum them up together. It also threw a 0 in here, because if you don't do that and you're passing an empty array, explosions of fire. And I knew there'd be an possibility of an empty array due to the fact that there were some ranges with no invalids. And then I finally returned the total. This here was an assumption of the problem. They were saying it, but I wasn't trusting it, that like, oh, just add up all the invalid IDs and you get the result. But I didn't want to build my entire thing on that assumption, so I didn't. Tested it out. Ended up being a waste of time, but it all averages out to being a saving of time. So let's refactor this a little bit, at least in isolation, before we do the final refactoring. We're just going to add straight to total. We don't need this array. Not in the slightest. And it works like a charm. I'm not really going to do any more refactoring. That was just the only thing, because it was a pointless juggling of values. But now we have part 2. So what did they ask of us? They asked the same thing, but they said that a invalid digit isn't something that is repeated, that is a result of repeating its contents twice. It's at least twice. So that allowed it to be not only the same thing cut in half, but also repeated or other combinations. So I think, yeah, all these are actually great examples. So I'm going to bring them down here to make it clear how these are great examples. So this one is the same problem. Well, the same thing mentioned from before. It's 1, 2, 3, 4. So, wow, that's a really thick line. Give me a small one. There's the duplicate point, right? Right in the middle. But for this one, it's 1, 2, 3 times 3. Boom. So 3 1, 2, 3s. This one, okay, I'm not going to do that. Well, we'll do it. But it's 12, basically, 4 times. So I'm just going to... this isn't monospace. Let's fix that. Wait, why does it say 4 times when I just had to go 5 times? 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. 1, 2, 3, 4, 5. It says 12 4 times. What's it mean? Is this a typo? Huh. I'm counting the number of ones here. 1, 2, 3, 4, 5, 6, 7. I feel like this is a typo, or I am not interpreting it correctly. But tomato, tomato, it can be any sequence, just repeated, making up the entire ID, makes it invalid. Which basically means, hey, there are more IDs that are invalid. Fix that logic, everything works. Now, the way I implemented it isn't too different from the rest of them. I did introduce deduplication, which I think was important. And I'm actually going to visualize how I knock this out first. And I'll pick this fine 12e12e12 thing. Probably the best one. I'll pick the 1, 2, 3 one. This is a better example. So what I did was I was like, okay, I need to see if I can duplicate any substring of this up to your length half to make the entire thing. So I started with being like, okay, I'm gonna take the one. If I repeat one enough times to build the original string, does it equal this one? Wow, this is not what I wanted. Come on, arrow, be cool. Be cool, arrow. Cool, arrow. What is wrong? Am I doing wrong? Oh, there we go. Yep. It's basically repeating this until to see if they equal. If they equal, boom, it's invalid. Otherwise, it's not. So I try with the 1. It's like, that ain't it, Buster. Then I try with the 2. So I repeat 12 until it equals the length of the string. Now this is the part where I don't actually know how this is working. Yeah, I think it's actually going one character more, one character less. So these are immediately being invalidated, but it's still trying anyway. So it builds that string, and it's like, are you the same? You're not? Okay. Dang on it. Try the next one. 1, 2, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. It does equal in this one. So this counts as an invalid ID. It doesn't stop though until it gets to at least the middle point. 1, 2, 3, 1. So it will try 1, 2, 3, 1. That's not 1, 2, 3, 1. And it will try 1, 2, 3, 1 again. I can't spell 1, 2, 3, 1. There we go. And then it will do it. I'm assuming it goes all the way off the rails. And then it's like, well, no, that string don't equal it. Keep going. And then I'm pretty sure it either does or doesn't include the middle one for odd length fellows, but that's the algorithm that I decided to implement. It's what mapped well in my brain. So that is the what of what I mentioned. The how, it's not that much different, honestly. First thing I'm going to do, see if I can. Well, we won't optimize it yet. But everything up to the original point is all the same. I do get rid of ones that are of length 1. Quokka, though, is showing me that this line's actually never fully evaluated. So I never needed to do that. That was an unnecessary concern of mine. But I then try every chunk size. That's what CS stood for in my mind. So chunk size of 1 all the way up to the middle point. I generated the chunk. And then I figured out how many times I needed to repeat the chunk to actually get to, at minimum, the length of the original string. So I'll do that. And I'll call this one an attempt. And then if it matches, I did the same logic from before, adding it to the original invalids. Now, I know this was useful because I did see some duplication at some point, especially with the 1s and the 2s and these really easy ones. The one where it's like 7 ones, yeah. Well, 1 7 times, that's a terrible example. If it was 1 8 times, then technically that would be counted as an invalid ID a bunch of times. So it'd be counted as an invalid ID for splitting on the 1. Oh, that's not. That would be counted as an invalid ID there. But it would also be counted as an invalid ID for being 4 11s. And it'd be counted as an invalid ID for having 2 1111s. But technically, it's a single invalid ID. So we didn't want to count this 4 times, just the once. So this is where our set actually was useful. We eliminated those duplicates. Yeah, that's Well, it works. So with that, the refactor is honestly if how many chunks you're willing to consider. So it's the chunk size, the minimum chunk size that's changing. Because here, the chunk size is always the string length divided by 2. But here, the chunk size is 1 to string length divided by 2. I'm trying to think of how to make that particular aspect customizable, aside from just chucking in a boolean, which always works. I can have a method that generates the minimum chunk size, and that will take in the string, and if we are in part 1, it will return string length divided by 2, but if we're in part 2, it will return the number 1. That's all I can think of at the moment, so that's what we're going to do. Okay. This will just be a good old function. Takes in ID, which is a string, and returns number. Well, in my case, I'm just going to be. Oh, I didn't make a type. I made a. No, I've done all this wrong. ID string. I'm declaring it. I'm not declaring the type of it. Let me fix this. Okay, that works. So I'm just going to let this be here. And then chunk size, I'll just set that to calculate chunk size. And I'll give these all really cool names later. Let's see if that does the trick. For 2, it should be seamless. 557. Okay. Let me see. Take the ID, and this one's going to return the number 1. Very complex. Boom. As expected. And for this one, I'm going to expect it to be returning the length divided by 2. Oh, it doesn't like me there. Off by a few. Interesting. So another aspect that's not really handled here is the evens and the odds. Well, great thing is that our test is what's failing, and it's the first thing that's failing, so that's a looky-loo. What are we looking at? Oh, please console log. Take all of it. Look at those 3-digit suckers. Okay, let's make sure this doesn't come into here. Aha, look at that, look at that, look at that. You can't be here. This is part 1. Okay, so how did you get in here? What is our chunk size? I really need console log for all of these. Chunk size, ooh, 1.5. Okay, so it starts at 1.5, and since 1.5 is less than or equal to, well, 1.5, it goes ahead. Yeah, me abstracting this to chunk size, not necessarily the move. And the problem with it is it being all fractional. Is it just... Is this just this? No, because it's still counting that 1 a bunch of times. It's not this, is it? I don't know how to spell seal. But I know how to spell seal now. Wake up. Oh, we just hit an infinite loop. Everyone stop. Stop. the presses. That was an infinite loop because it was greater than that. We can seal you. And then sealing this one will be safe. I lied. It would not be safe. Okay. Get too fancy for my own good. Put the floor back. I'd like to be fancy, though. This would be so cool if it were fancy. Now, the problem is that the 3-digit odd fellas are still making it through, in particular for those. I mean, I can throw it into a variable and then do a check before it. I'm not thinking of a cleaner way of doing this, which is annoying me. Why didn't this work? I'm gonna look into this, why this didn't work. It should have worked. Yeah, so we have a CS of ones and twos, ones and twos. And if I seal you, yeah, I will have to stop Quokka. It's gonna fire everything. Oh. Ah, I forgot I had the thing in here. I'm so impatient. Forgot. Get out of here, you slow running piece of code. There you go, that did the trick. Oh, hey, I'm also... Oh, no, okay, all good. Okay, so it does work. I was just being impatient. And I am adding to the computation time because running this seal every time is bad. So last middle, boom. And then let's give these some actual good names. Chunk size. And then you're called an ID. Let's call you an ID. Middle length. Middle is something. It's good enough for now. So we have the ranges that is used only once, so we can inline that variable. The invalids, which we can rename to valid IDs. We love it. First to last, I'm going to rename this back to current, which I did in the original refactor, but it didn't make it in. Spell current correctly. Yeah, that is good for every ID. Calculate the middle just for efficiency purposes. Go through all the chunk sizes first by calculating it. I was about to see if I could optimize this away. Unfortunately, it depends on the ID being calculated, so no. I could optimize this away knowing that it's based on length to basically cache it, but I don't want to. I generate the chunk and then repeat the chunk that many times. I don't even use the chunk. I inlined it. I don't know if I did use it. Okay, well in this case, I'll put the chunk here instead of slicing the string twice. Repeating it that many times to get the attempt. See if it matches the original ID. And if so, add the current. The names aren't the best, to be honest. Again, another opportunity. These two can be encapsulated to their own logic, but it's fine. Ooh, you know what? Let's do it. Let's go a little fancy. No one's gonna stop us. Yeah, we'll do a little bit of functional with a little bit of non-functional right there. So now we get first and last right there. That's not terribly fancy. It's still readable. It's a little fancy though. Get the ID, which is current string. We do still need current though. So, I mean, this is technically current ID. And this is what? ID string. Again, I can do the math. I can do the divide by 10. Decided not to. Let's give this something better. Oh, actually, AI, pretty good. Halfway point. So, chunk size, we love it. We generate the chunk, we repeat the chunk all that times. Invalid ID. See if it matches the ID string. Don't necessarily need to use that here, but we're here now. It's fine. If so, add to it. Turn it back into an array. Sum it all up. Your uncle's name is Bob. And both of these still work. 262 557. Oh no, I broke it. Ooh, nope, don't tell nobody I broke it. Probably gotta deal with something around here. Is this at least still working? Oh no, everything's broken. Cool, cool, cool. This is what I get for not actually keeping these tests running. Well, aside from my failure of a refactor, this is logically identical. I'm just doing something funky. See if I can spot it really quickly. Otherwise, I'll just squash it later. Can't start Control Zing. I prefer not to do that. It's also the fact that all my tests are working. Slightly concerning. So let's see, am I adding too few or too many? That'll give me a direction. So that's the right answer. It's the wrong answer. I'm adding too many. Okay, so that means something that isn't an invalid ID, I am making an invalid ID. Is it a string.length one thing? Did this come back? 2033, 2033. Aha! Okay. So when I made it this generic, then things of length 1 did make it through. Neat. Well, I could just straight up, if current ID less than 10, get out of here. Not concatenate. Don't know where that came from. Get out of here. Nice. I bet this one's going to work now, too. See, that one's 1889 and 2033. Good, good. 8557 and 2620. There we go. Okay. And honestly, these could be minned and maxed accordingly, but it's fine. Oof. Modify the data. Handle the bad data wrong. Tomato, tomato. Different ways doing the same thing. Yeah, that is the problem, the refactor, the solution. Pretty fun one. Can't think of any immediate plus ones to this, honestly. The last one was very good with that whole clock and the dial thing. This one I could see being somewhat gamified or even visualized to show the algorithm, the search, the matching, stuff like that. But we will see what I come up with later. With that, that is another advent of code down. Let me commit this real quick. solution is pushed. Oh my gosh, yes, please go to the GitHub. And with that, we're gonna call it, and I will be back tomorrow. Bye.